Okay, let's look at the basics of some connectors. The first thing is you've in normal standard connectors you have a 180-degree 5-pin DIN connector. Now this DIN connectors, most applications are just going to use the ground wire and a pair of balanced conductors or conductors that carry a 5-volt signal. As far as I know, it works out to a 5 milliamp signal current. So it can only carry the information in one direction. So you're actually going to need 2 cables if you want to have it going both ways. And the other 2 connectors, you can look at the connector pins shown here. The other 2 connectors are going to be used. Sometimes it says here for phantom power, like a foot controller or something like that. And sometimes they can be system specific. So we've already talked about system specific things. So 1 or 2 of those other pins may be assigned to a specific instrument with a specific format and protocol that it's been set up for, but that the basic, transfer of information is going to be, it's got the ground and the balanced pair of conductors. So that's real simple to understand. It does say that it has an opto isolator, and I'm not going to get into what that is, but it just basically it keeps the device from actually grounding, getting ground loop. So it's not actually, the electrical current isn't actually directly attached to whatever devices that you're working with. And they've set up a 15-meter maximum for the cable because it seems to be having some issues with noise. So it's to limit interference is the way they put it, but basically that just means they're having problems with noise that's going through it. So if you're going to be dealing with that, I'm not sure, but I would think the best thing to look at for that would be different types of connectors that are going to salvage the signal and then send it back out again as the original signal. But I'm not sure that that's very workable as far as what they're saying. The other thing is going to be management devices. So let's take a look at that. All right, the next most basic connectors are going to be through boxes, mergers, and switching boxes that you can get all in one in patch base. And what that does is basically the understanding of it is as the signal goes along that you're going to get delays on the signal. So putting it through boxes, that way that you've got a box, a through box, or a MIDI patch bay that's going to have multiple inputs and outputs so that it can send it off to other devices to avoid that delay. And also mergers that will actually merge different MIDI signals together to go to some other system or some other instrument with a combined MIDI signal, and switchers to actually switch without having to readjust cables or reconnect cables in some other way. So that is a basic, when we had talked about before about, all that stuff we were talking about routing all over the place, that those are the basic devices to do any routing. One other thing about the routing is the routing can also be set up with computers. So you can also actually set it up with software that's going to actually be set up to only do routing, that it's actually going to route that. So you're going to have input coming into it. I'm not sure exactly how that would work. So, for me, it's not real applicable, but I would imagine you'd have to get some very specific equipment that's going to use your computer or computers in series to route all this MIDI information in different ways if we're talking about a really large system. So depending on how far you take it, the actual connections that, when we had talked about all the routing, that they've got it mapped out pretty well. And with those few, connectors or patch bays that actually the system is going to run about wherever you want it to run. And as far as I can tell, that's not that complex. The actual signal flow can be complex, but the actual routing of it's been mapped out pretty easily and pretty simply so that you don't have to, it's not a real complex thing that there's a whole lot of things that you'd probably have to take into consideration while you're mapping that out. Unless the system was huge, that it's got a pretty good basic general mapping of the signal flow with those type of connectors, which seems to be very user friendly. And one other thing we had talked about were like system exclusive messages. This is real. It's defined very clearly that like the MIDI implementation chart, so that whenever you're getting a specific instrument or software or anything like that, that it should have a very specific MIDI implementation chart that's going to cover all the topics we've talked about with MIDI, that's very specific to that instrument. So that's very helpful, and it should be mapped out very directly related to the general mappings that we've talked about as far as MIDI, so that, you know, any changes in those parameters, or, you know, that structure should be very obvious and easy to understand if you understand the basic MIDI structures that we've spoken of. And we're talking about electrical specifications. One of the cool things about this is that, you know, it's not transferring any audio information. It's just, it's a pulse train, or varying degrees of a pulse train, what's happening there. So the cool thing about it is distortion and noise. You can have a fairly good degree of that going on without having to worry about it too much, because it's basically trying to transfer some binary information, and as that gets worse, it can cause some issues, but the issues probably shouldn't be as drastic of things to have to deal with as like dealing with audio. So that's a huge plus. There's a basic electrical specification for the cables and things like that, but I really the cool thing about it is it's set up basically that we've already talked about, you know, how it's transferring information, and, you know, the protocol in the cables, how it's transferring it. And it's set up fairly well to where that basic information, you know, is going to be fairly well isolated and shielded from any kind of interference. So that's a really good thing to take in consideration, and that they've taken the consideration of standard cable lengths, and they've probably taken the same considerations in all of the hardware and connectors and through boxes and splitters and mergers and patch bays like that. And the cool thing about that is a lot of that stuff doesn't have to be that high tech to deal with that basic binary information and the way the media is transferred. So that is a really cool thing. You can look into the electrical specifications if you'd like to, but for the most part, the basic fundamentals of it and the basic concepts of it, you probably shouldn't have to worry about too much for most real basic applications. All right, the general MIDI and general MIDI extensions are basically set up to where that you've got sounds, and they're arranged into certain specific, you know, signals and binary information. That way that if I play on here and I'm playing a piano, and I give somebody a MIDI file, that on their system it's going to play the piano also. That's not going to be real pertinent with basic MIDI information when you're working with it in a very basic, general understanding of it or general usage of it, like we were talking about. But you can get on there on that MIDI.org, and it'll actually show you. It's got a family group of 16 that has a general family group, and then 128 the patch map for the instrument names and what number they are. And there's 128 of them. And also a general MIDI level 1 percussion key map, so that's mapped out also. Now that may or may not be real pertinent as far as what you're working with, because a lot of times in the things we're talking about, we're dealing with general basic MIDI information that we want to work on in the studio, and so we're not worrying about that too much. Some of that can be real applicable when you're trying to make a MIDI file that's going to be played on something that's going to be using whatever sound card and whatever instrument they're using. That if you wrote that MIDI file on the piano here, that when they play it on their equipment, that it plays the piano also and not a flute. So, that's the basic understanding of that. And the setup is real easy, and it's very well configured. And, you should read a little bit about it on MIDI.org about how that's set up. But for what we've been talking about here, most of the time that we're not even going to be hardly dealing with that much. So if you are dealing with that and you're sharing MIDI files that are going to be using the patches and the general patches or extensions of them, that you should read about it. For myself, that I don't really care. I'm wanting the MIDI information. And sometimes that might be, if I'm dealing with some certain instrument or something like that, that I more than likely am going to be dealing with that in the studio about how I want the, you know, all the different types of characteristics, you know, to be attached to those MIDI, basic MIDI and compositional notes later. So that's something you're going to look into if that's what your use is going to be. All right, MIDI timecode. You're talking about MIDI timecode. Most of the things that you're working with MIDI, that their internal clock is going to work fine with themselves in their own application or own hardware instrument. But you're going to have to worry about the MIDI timecode when you're trying to, the system contains multiple sequencers, or they're going to have to be synchronized. So at that point, then, you know, you're going to have to connect them, and one of them is going to have to be the common for the MIDI timecode for them to share, so that basically they're in the same, you know, on the same wavelength as far as timing and tempo and things like that. It's a real basic concept, and try not to get it too complicated. Some of the things about it can seem complicated, but basically the concept is that simple. And the SMPTE time codes are basically frames. So if you're dealing with video or filmmaking. All right, some of the other things that we're talking about here, MIDI machine control, MIDI show control, MIDI time stamping. I mean, that's pretty obvious. It's just, you know, I mean, a lot of these are just automated things that are actually part of the MIDI that you probably shouldn't have to worry about it too much unless you start having issues, you know. And if you start having problems, you might have to look up some of these things. Alternative hardware transports, USB and FireWire, XLR connectors, different things like that, Ethernet for, you know, if you're working on the internet or something, wireless, and even, you know, audio jacks that, you know, that some of them will connect with. So I think we've basically covered most of the topics and the general topics as far as MIDI is concerned. So, I mean, you know, the basic thing is at this point that basically we've done a basic outline of MIDI. So what have we learned? We basically understand that, you know, as we're dealing with MIDI, that it's going to be very specific. The basic functionality of it, we've addressed, and I do suggest you go to that MIDI.org and go through it there, you know, and spend, you know, an evening or two and just read through all the information that is there, and so you can really see how it might be applicable to what you're doing. And also look at the hardware and software you're working with, and you know how its systems are related to MIDI, or how it relates to MIDI, what kind of protocols and formats that it's using. And if you go through that, we've addressed most of those issues. So, you know, if you run into other issues that are directly related to your system, your software, your hardware, or your routings, or some complex system that you've made, then we've addressed the basics so that you have some idea in a direction to go. But, you know, we just kind of wanted to address the basics of MIDI so that, you know, it's, you know, a very simple application that, you know, does some really cool things. When some people, you know, talk about it, some of the things can sound like they're really complex, but, you know, just if you start, you know, you've got the basics, and you know, build out there the much more complex systems that can be built with it, or it can be used for, that you'll probably find that, you know, a lot of the basic concepts will apply to the system that you're working in, and will become more complex as you need them. And so, you know, my suggestion at this point is to go to MIDI.org and just go through that. Look at your system, look at your software, look at your hardware, and look at their, you know, after you've gone through these videos, go there and peruse through that, and go get some specific answers for things or questions you might have. Because the basic outline we've already discussed, and what it can be used for. I've told you that what I use it for are very basic applications, because that's its functionality for me, to keep it as simple as possible to do what I want it to do, and it does a great job of it. I hope you enjoyed the series. Peace, hope, love.